Good morning. This is my presentation on how the nervous system works. And to demonstrate it, I'm going to use a bunch of the toys that I found lying around on my daughter's floor today. So, if you look at the body of this nervous cell structure and the synapse, we have basically a cellulose form that's known as the soma. And inside that is going to be the nucleus of the neuron itself. And that is the basic nerve structure. But how they communicate with each other is an entirely different thing. So you have this long channel between one cell neuron and another. This channel is known as the axon. It is surrounded by a myelin sheath. And if you recall a movie from some years ago called Lorenzo's Oil, the son in that movie, Lorenzo, had a disease that was eroding the myelin sheath around the nervous system, and that was what protects the nerves from being damaged. So Lorenzo's body was being slowly destroyed by the erosion of this myelin sheath. But the axon and the myelin all come down to an end, and this end contains some vesicles, which are tiny little things in the end of the nerve system. And these are the things that actually do the communication. This is going to be a gross oversimplification of what really happens, obviously. So we have the two nerves, and they're very, very close to each other. This is magnified many times, millionfold, in order to see how the communication actually works. So what happens is a stimulus happens, and whatever that stimulus is, whether it be chemical or physical, and that triggers an action response. And this action response heads down the axon in a wave that's lightning fast. And when it encounters these vesicles, it slams into them and causes them to scatter, and they jump across this gap. Some of them land on the other side, the synapse, and some of them do not. And I suppose this is a terrible analogy, a car running into all of these cute little animals, but so be it. So the action response travels down the axon, strikes these vesicles, and some of them leap onto the other side and they stick, and some of them do not. And that's what causes the communication. Again, this is another gross oversimplification of really what happens, because there's an exchange of potassium and sodium ions that causes this polarity shift from one nerve ending to the other, and that's how the message gets sent across the gap to the other nerve. And when the action response is over and the signal has been delivered, this polarity, the sodium and potassium polarity, returns to normal with this equilibrium balance, in which case these vesicles that belong here on this side slowly come back over. And when I say slowly, I still mean a very, very quick response, just slowly in compared to the transmission of the signal. And that right there is, while overly simple, how two synapses communicate with each other.